Hi, today we're going to be working on activity 2.3 and 2.4. 2.3 is a longer page, so there's going to be some things I will be cutting out, and 2.4 is a pretty short. Tomorrow we will work on the assignments page, and then I'm giving you time to work on the formative. Um, Make sure maybe on a sheet of paper later you write down the different formulas that you can use for the formative that we've done so far, just so that you have it. So I would write that on a separate sheet of paper after you're done with this video, kind of go back through the packet and write down the formulas that we've talked about. So we're going to get started. A dog is tied to the corner of his rectangular doghouse with 10-foot chain. The chain keeps the dog within 10 feet of the corner. Okay, so pretty simple. We can kind of see right here is where the dog is tethered up, which I'm hoping you guys know that that's calling for the radius then, is what that's saying. Um, just as reference, okay? Determine the area of the sector created by the 10-foot radius, okay? So we're sitting here having to figure this out. Now, if we stop to think and look, this is where we have to be very observant on things. This right here is saying this is a right angle right here. So we know a right angle is 90 degrees. We know a full circle is 360. So obviously the dog cannot come inside where the doghouse going around it. So we have to subtract 90 degrees from 360. Okay. By doing that, we should be left with 270 degrees. So remembering our formula of area equals, I'm going to write D for degrees, 360 times pi times radius squared. We know that our degrees we're going to be doing is 270 over 360 times pi times, and I already told you our radius is 10, so we'd write 10 squared as our radius, which ends up coming out to being, reducing this down, 27 over 36 ends up reducing down to 3 over 4 times 100, because 10 times 10 is 100, pi. Okay, now we multiply this in, ends up leaving us with 75 pi, and if we times this to get the exact answer, so 75 times pi, so going to our handy dandy calculator, sorry, screen's turning, if we hit second, actually we're going to type it this way first, so we're going to type in 75 second key, and you go all the way over to where your divide sign is. It's the one above where it looks like a caret, gives you pi, hit enter, and it gives us 235.619. We're going to round that up to our area of equal 235.62, and because we know that they are measured by feet, we're going to put feet there in with our answer. Okay, that is actually our answer to problem 1. I probably should have mentioned that, but we were solving it right there. So it's telling us determine the area of the sector created by a 10-foot radius. Our answer is right there. Of our sector is 235 feet. So essentially this dog has 235 square feet to walk around this area. Now they're asking us, what is the radius of the smaller sector? The small sector, what they're referring to is this one right here. And I'm going to show you a tip on how you can figure this out. So the radius of that, they may not tell you how many feet this is. We're not sure. But guess what? If this is 8 feet, and we know this is 10 feet, we set this up as 8x plus, or I'm sorry, 8 plus x equals 10, and I'm hoping maybe Bashir or Jacob will screw this up. Just giving you guys a hard time. We minus 8 on each side. Leaves us with x equals 2. So that radius is 2 feet. Okay? So that's all you have to do. Okay? Because we know it's 2 feet longer than the doghouse. So determine the total area or space the dog has to play. So now, this is including adding the doghouse. Okay? So whatever we have to do, it's going to be 235.62 plus whatever we figure out the doghouse to be. So if we look at the doghouse, we know it's 8 feet tall. We know we have to use the same formula that's up here in the top corner for this. So now we know that's 90 degrees is where that doghouse is. So we have to set up 90 divided by 360. We're going to times it. Actually, I'm sorry, we're not including the doghouse. I'm sorry, we're going to include figuring out what this little red that I'm shading up in the top corner comes out to be. Okay, so we're going to times that by pi, times it by 2, because we found out that's 2 feet squared. We should know 2 times 2 just leaves us with 4 pi then. Times, reducing this down, 36 and 9, or 9 and 3, 36. The common is a 3. Actually, I will say this, the common is a 4, because 9 divided by 9, or I'm sorry, I'm misspeaking. Common number is 9 for each, because 9 divided by 9 will leave us with 1, and 36 divided by 9 will leave us with a 4. So that's 1/4 is our comes out to be. Next, you multiply this in. 1/4 of 4 just ends up canceling each other out. So we're just left with pi. So to solve this, then we're just going to add pi, so 3.14, to our 235.62 total, which comes out to be the dog has 238.76 squared feet. That's telling you how much room he has to play in his area. Okay. If this does not make sense, I will go over this again once we come back to school to help make sure we are all on the same page. I am not going to do this sprinkler stuff because I don't want to confuse you guys on that already. So we're going to skip the rest of this. And we're going to go into, told you this one was long, we're going to go into 2.4. Okay, I will go over that in class when we come back. I just don't want to deal with the sprinkler system on that one with you guys. There'll be a lot to deal with. So, looking at our next part here. So, velocities in circular motion. Two types of circular velocity are linear velocity and angular velocity. Linear velocity can be described as an amount of distance over a specific amount of time. Linear velocity can be expressed as v equals s over t, where v is velocity, s is arc length, and t is time. Use the formula to determine the linear velocity of a point on a circle that travels 24 centimeters in 8 seconds. So looking at number 1, we're trying to find out what velocity is. Okay, so we're going to use this formula right here. So v is going to stay the same. Time is 8 seconds. So we know that's going to be at the bottom, over, and then we know they're asking how far we're traveling, so the arc length, feet, whatever, is 24. So I'm going to write 24 cm and 8 sec for seconds. Right there alone, let me erase some of this for you to clarify it. That is writing out that problem. Okay, so using the formula, you were able to just write in this problem right here. Okay, so that's going to be something you may need for the formative tomorrow. Angular velocity can be described as the amount of angle movement in radians over a specified amount of time. Angular velocity can be expressed as, I'm going to highlight it here so you see, a W looking symbol, where the W symbol is angular velocity equals the theta symbol, angular measurement, so the radians, over t as in time. Okay, so essentially the W is like what the arc length is almost like. Theta is what the angle measure is pretty much like, and t is the time. Okay, so radian does not come in right here, does not come into play right now. Okay, so I'm going to leave this zoomed up this way just so you can see it. So number 2 is asking us to use the formula to determine the angular velocity of a point that rotates through 3 pi over 4 radians in 6 seconds. So we pretty much have everything we need to set up from this equation. So I'm going to write the problem right here over theta over t. Okay. So this is our theta, so we can write 3 pi over 4 over, because we're going to go over time, which our time is 6 for 6 radian, is W equals to this. So that's our formula we have to write. Now we have to do our reducing. If we go into our handy dandy calculator and we do alpha, so the green button, top left corner y equals, and hit enter and type 3, we're going to have to do this to make it easier. Type this first, then we do it again, alpha y equals. It's going to give us a fraction over a fraction. So this is where we type 3 over 4, and then we end up hitting 6 to make a fraction over a fraction. So you hit alpha y equals, enter, alpha y equals again, enter to get the first fraction. So we put the 3/4 over 6, which gives us 0.125, which I know, and you guys may not know, 1.25 is essentially 1 over 8. Okay, so we're going to go back to our problem here. So we know to make this reduce, we know this ends up coming over to being 1 over 8, and we have to end up leaving pi at top. Okay, so next, we end up taking, how do they get that part? That's our answer, I'm sorry. So that's just our pi over 8 essentially, and it says radian / second is our answer. Okay, I know it's a little complicated, and that's why you use a calculator. That's why I told you guys to get that app to help you calculate this. If we look at 3, because 3 is our last one we're doing today. Okay, it says a car tire with a diameter of 60 centimeters turns with an angular velocity of 6 radians per second. Determine the distance traveled by the tire in 5 minutes. Okay, so we're doing 6 radians, so 6 rad over 1 for a second. Okay, equals RW. Now we know in 1 minute, because there's 60 seconds in a minute, our radian ends up being this. So if we get 6 radians a second, so in 60 seconds to a minute will be 60 times 6, which gives us 360 radians per minute. Now we have to find out 5 minutes. So we take 360 times 5, and that comes out to being 1,800 radians. Okay, so our theta, that symbol that I just drew, is equal to 100 or 1,800. Okay, now how do I want to write this in? They end up, you know what, I'm okay with us getting to this part here. Okay, if you can do that, that's all I'm going to ask you, because the rest of this gets thrown in multiple equations that will confuse you guys right now. So if you can give me that, I'm okay with that part right now. Okay, now, as I said, tomorrow we will be having our formative and our doing the assignment page. Okay, that is our assignment for tomorrow. If you have any questions, please reach out to me and I will help you with anything you need help with. Thank you. Have a great day.